Hello and welcome to another video. In this video we're going to be working on shifting letters 2. In this one you have a string of lowercase English characters and an array of shifts, where for every shift you want to shift every character in S from the start index to the end index to the right by 1 if the direction is a 1, or to the left by 1 if the direction is a 0. And a shift just means take whatever character you're at, let's say here. Shifting to the right means you make it go to the next. And shifting to the left means you make it go to the previous, and you loop around. So A will go to Z, Z will go to A to loop around. So let's just take a look at these examples. So in the beginning we have ABC, and then we want to do a shift on these two characters. So, and we're going to be shifting them left. So A will go to Z, B will go to A, and C will stay the same. Then the next one is you want to shift the last two characters to the right. So these two, and then you will get Z, B, D. And then the last one is you want to shift the whole string to the right. So A, C, D. And in the second example, so we have DZ, TZ. So you want to just take the first character, shift it left, so D will become C. And then you want to take the second character and shift it right, so this will be A. Okay, so looking at constraints and like figuring out a plan to solve this kind of problem. So the string is 10 to the 4th, and the shifts is also 10 to the 4th. So you can't just like manually go through every shift and just change the characters manually, right? Like you can't just be like, okay, let me take the string, turn it into an array of characters, and then for every shift I'll just loop through the indices and shift these, because that would be unsquared essentially, or not unsquared, but that would be like n by m, where n is the string and m is the shifts. That doesn't really work. So you need something faster, and also something like ideally you want to know quickly how fast these shifts happen. So either do something with the string to make these shifts happen in O of 1, which isn't really possible, or figure out how do I like do all these shifts together somehow. Maybe like do something with the shifts and then just like get this somehow. So that's typically how these things work. It's like either go through one or go through the other, and then do the other one after that, and not try to like do a nested for loop. So either go through this and then be able to do these in O of 1. That's a common pattern for like, this might be some queries and do some optimizations here, or go through this and then be able to get the string just by going through it. And in this case, we're actually gonna be able to go through the shifts and then be able to get through the string. And in this problem, so typically when you have these like interval type of problems, this is kind of an interval, and you're modifying values, what you can do if you want to know like what's the value at a certain index, and I can process all these intervals, is you can use something called a line sweep. I think I talked about this in previous problems, but essentially what you do is you make a number line of all the indices you have. So like, let's just go through this example. So essentially all the indices we can have here is, let's actually use this kind of, so we can have index 0, index 1, index 2, and then index 3, which will just be the length of the array. And all of these are going to be 0. And this just represents like, this is how many shifts I have at this index. So when I'm at index 0, I have no shifts, no shifts, no shifts, no shifts. And now what you can do for these intervals is you can figure out, okay, where does it increase and where does it decrease? So this first shift, essentially, because we're shifting left, we can represent it as a negative value. So we can just say like, this is like moving every character times -1, which will just mean it'll go left 1. So we start at index 0. So this will be a -1. And then we want to, after this interval is over, we want to replace it with this, or we want to do the opposite to kind of like cancel out that operation. And so actually at index 1, this character will be shifted as well. So the character we actually want to replace is the one right after the end. So we want to replace the character, like if this is an XY interval, we want to replace the character at X and then the character at Y plus 1. So here, we would just replace this character with the opposite of what we did. So this would be like +1. And same thing here. So interval 1 is here. So we're shifting right, which means we're adding. So we're going to add 1 here. And then we're going to replace, or we're going to do the opposite at 2 plus 1, which is here. And then finally, at 0, we're going to add 1. So this will be a 0 now. And then after 3, we'll go -2. And now we can actually use this to build up our word. So let me show you how to do that. So let's say we're going to have like our original word with these indices. And and these original characters are A, B, C. And so these numbers are going to be like modded 26. So they're going to be, you know, if they're bigger than 26, they're just going to be anywhere between negative 26 and 26. So we're going to say, okay, well, for the A, it's 0, so there is no shift. So this A stays in A. For the B, it moves to the right 1 because there's 1 shift. So essentially you can just do like, you just take whatever the character is here, add 1, and that'll be the next character, that'll be C. And then here for the C, we're also adding 1, D. And then we don't do anything afterwards because like this is the whole thing. Actually screwed this up somehow. So this should be E. So let's double check this real quick. So 0, 1. So this should be a -1. Yeah, so this is -1, and then this should be a 1. Then here, oh yeah, I think I didn't subtract here or something. Yeah, so this one, so yeah, basically like going back after the first operation, it should be this -1, and then here we have a 1 because we're going left. Here we change this. Oh no, actually no, this was actually right. So this was actually the right number. I just missed a step. So let's go back to our original word here. Yeah, okay. So the thing that I missed actually here is you don't just take the value at the index, you maintain a running total, and then at every cell you modify your total. So essentially what would happen here is we'll have like a cur value, and then it'll start off as 0, and then we'll just like add the value we're in here. That's what I missed. So here it will be 0. Here we're gonna add the 1, so cur will be 1. So we're gonna do 1 shift, which will be a C. Here we'll add a 1 again, so it'll be 2, and then we'll do 2 shifts, and that'll be E. So that's the step I missed basically. Essentially you keep track of like every index where a value changes, and you record like the cumulative there, and then you just have a running total, and then once you get the total for the cell, then you just take your letter and you shift it by whatever this number is, and that's basically it. So yeah, called line sweep, kind of useful for these like interval problems, and it does come up in decent amount on like medium to hard problems, so good to know. Okay, so let's code that. Okay, so the first thing we're going to do is we're just going to get like the length of the string. Then we're going to build out this line to figure out like what the values are. So line is just going to be int array, and it's going to be length of s plus 1 because we wanted to go from 0 to the length of the string. Now we're going to loop through every single value in the shifts and then modify our line. So we don't need the index, so v shifts. So we need the x, the y, and the direction. Yeah, and that's just going to be v0, v1, v2. Okay, so if the direction is negative, yeah, if the direction is, or it gets 0, then at the x we want to subtract 1, and then at the y we want to add 1. So we can say line x minus minus. We do also need to check that we're not out of bounds, because remember, we're not adding 1 at the y, we're adding at the character after the y here. So actually we should never be out of bounds, so this is fine. So we can just do line line y plus 1. This is fine. And so the opposite. Okay, otherwise we're basically just doing the opposite. So at the x we'll add, the y subtract. Okay. And now, so this will give us our line. Now we have to actually build the string, and then you can use a string builder, similar to Java. So import strings, or you can use like a byte array or something, whatever. Okay. And then we're gonna have a running total, so we'll just have like a total or something. And then we're gonna loop through every character in the string. And we're gonna increment our total by whatever value we have in the line. So, and then we're gonna calculate like our shifted character, essentially. So shift, or this will be like an int shift. So int. So we're gonna take the character at the string we're at minus a, because that will give us like the normalized value there. So like if the character is C, then we'll get 3 there, and so on. So we get the normalized character. We're going to add the cur, which is like the shift, and we're going to mod by 26. I guess this should be total. So total. Okay. And now if our shift is negative, we're just going to add 26 to make it positive, because it's the same thing. Like shifting to the left, 2 is the same thing as shifting to the right, 24. So we can basically just always have a positive. Okay, now we're going to write the character. So write, and you can use write byte there. So we want the shift. So the shift is an int. So we want to convert it to a character. And this is a normalized character, remember? So we can just do byte shift. And to make it go to an actual character, like if this shift was like 3, for example, that means this character would be like 3, but we want it to go to the character a plus 3, so we can just add a back to it. And we can return the string builder to string. Okay, let's see what happens. All right. Okay, so it seems to be working. So this is fine. Yeah, essentially, like, I don't really care about the complexity too much. Like, it's big O, as good as it can be. Maybe you can do some other stuff to make it a little bit better, but yes, essentially this will be time n plus n, where we're going through the string once, and then we're going through the shifts array once, and then the space. So we did store this line, and this line is just n, where n is the length of the string. Yeah, so a common pattern when you see this, like you have something and then queries and you can't do the queries in a brute force, basically it's always going to be optimize something in here to make the queries in O of 1, or go through this to make this result in O of 1, one or the other, essentially. So yeah, so that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.